Hello, so this will be a demonstration of the Raspberry Pi security system. Currently it is in the disarm state, so let me go over how this device works. So what this is, despite the blue appearance, is actually a Raspberry Pi, connected to a Grove Pi shield, which itself has many connections to various Grove Pi sensors. So the main sensor, the most important one, is this ultrasonic rangefinder. Basically, the idea of this device is that it will be hooked up to the door of like a vulnerable room with valuables, or maybe a safe or something like that, and the distance between the device and an adjacent wall will be pre-recorded and inputted into the configuration of the system. And once this device is armed, this ultrasonic rangefinder will calculate the current distance between the device and the adjacent wall or whatever. And if the current distance is not, say, within a small threshold range, accepted range, say it is too big or too short or too small, then the device will assume that what happened was that somebody opened the door or got past it and breached the vulnerable area, and thus it will trigger the device and it will go into the triggered state. And as for the other things, as you can see, this LCD display is just displaying relevant information. We have a rotary encoder, which is used to sort of cycle between the different options. As you can see right now, it's press button to arm, but if we turn it a little bit, you can see that to change, now we can change the distance, and that's just cycling through with the encoder. And to actually select the different options, we use this button. And we have two LEDs that will blink depending on the state. So let's do a quick demonstration of the when this device is triggered and the combination is not entered correctly. So as you can see, there is a brief red flash, which signifies that the measured distance is different from the pre-recorded distance. I believe the measured distance, or the pre-recorded distance, is very small, just to make this easy. But that's why it immediately goes into the triggered state. And so basically we have about 35 seconds left to actually input the correct combination, which is 20-20-20. But let me demonstrate what happens if you don't input the correct combination. So we get a brief red flash, it's 000, and if we were to try again, we can use the rotary encoder here to change the numbers and try to do it again. Let's try 13-13-13. And we try it again, and nope, doesn't work. So we don't know what the combination is, or we didn't input correctly, and now it goes into the final triggered state. And as you can see from my phone here, we did get a message saying that somebody has entered the device, or entered the room, and my alarm has been triggered. So that is the main purpose of this system. But as I was building this, there was one issue that I ran into, not with sort of the code necessarily, but how the system would actually work in the real world. Because I noticed that it could be very simple for an intruder to disable this device. They could sort of destroy it with a blunt object, or they could just disconnect the power before the countdown from 60 to 0 is up, and that would prevent the user from being notified of the intrusion. So I thought of adding a second Pi to act as a server for this Pi to communicate to whenever it was triggered. Basically what happens, and let me reset this in the meantime, as I explained. So as I said before, combos 20-20-20. So it resets the device, and now if we change it, we can arm it. So in this minute, let me explain what this server does. Basically, every time the device on the right, the actual main device, is triggered, it will send a signal to this device saying that that it was triggered, and to wait for a disarm signal to be sent. And if the disarm signal is sent, then this one knows that the owner was able to actually disarm the device, and so this one doesn't have to send it. But if it doesn't get the signal, which, let me disconnect this, if it doesn't get the signal from this device because this device was powered off, like I just powered it off right now, then after a full minute from receiving the triggered signal, it will assume that this device was destroyed, and it will take the responsibility of sending the notification to the owner. And as you can see, I just got a text message from Twilio. Let me open it up, and you can see that 5:56 p.m., 5:57 p.m. that this server was able to successfully send the notification to the user. So that is the sort of gist of this system and why it is composed of a server and a client, just for increased, or to ensure that the user is always notified of intrusion. So stay tuned for more updates on the final product, especially making this whole device into one neat package.